Okay, so we are going to take a look at Lewis structures. Lewis structures are our first step to understanding what things actually look like at the molecular level. So Lewis structures are just going to kind of give us what they actually look like. So first of all, we're going to have a set of rules for Lewis structures, and we're going to do. I'm going to do an example alongside my little demonstration here. So we're going to start with let's do SO2 as our example. So we're going to start with SO2 as our example, and let's take a look at the rules for Lewis structures. So step one for Lewis structures, we are going to count total valence electrons for the structure. So count total valence electrons. That's the first step. Now, when we're looking at a structure, we are going to look at the group number to know how many valence electrons we have. I know that sulfur has 6 valence electrons because it's in group 6 or group 16, right? And I know that oxygen is also in group 6, so 2 times 6 electrons, because there are 2 of them. Each of those oxygens is going to bring 2 electrons to the party. I'm going to add both of those up, and I'm going to get a total. So 6 plus 12 gives me 18 electrons. This number right here is the final number of electrons that I'm allowed in my structure. My structure will have 18. It will always have 18. And for this class, you should always have an even number. Okay, so we're going to have 18 at the end, and that's always what we're going to check. Do I have 18 electrons? In fact, we're going to count along the way until we run out of electrons. If you do this properly, you should end up with 18 electrons in the end. Step 2, we are going to we are basically going to create a skeleton structure. So skeleton structure with 1 bond to each atom from the central atom. So this does 2 things. So first of all, this means that we have a centralized atom. Okay, so in order to know which the central atom is, the central atom equals the least electronegative or most electropositive, but really is the furthest from fluorine. The one that's furthest away from fluorine is going to be the central atom. Okay, just a couple of quick notes on that. Carbon is always central, and hydrogen is never central. We're going to talk a lot more about hydrogen, and I'm going to mention it now, and I'm going to mention it again. Hydrogen is always going to have this configuration. It's never going to have anything other than just 1 bond. If your hydrogen has anything other than 1 bond, you've done it wrong. Okay. By the way, group 17, the halogens, fluorine, chlorine, bromine, iodine, generally they're never the central atom. They're generally in the peripheral atoms. But you can often look and see whichever one is listed first or alone is generally the central atom. So the first one listed is generally the central. So just another thing. But we have to decide, we're drawing this skeleton structure next. So in this case, sulfur is further away from fluorine than oxygen is. And so I'm going to put sulfur in the center. And I'm going to create 1 bond to the 2 oxygens that I have. I'm just going to spread them out as much as I can. Let's just distribute them as evenly as we possibly can. Okay, so a couple of things. I have just used, let me move this a little bit. I have just used 2 electrons. This bond right here has 2 electrons. This bond has 2. So I have used 4 electrons total. This is from the 2 bonds. Okay, so the 2 bonds that I just used, so I'm down to 14 electrons left to add to my structure. Okay, all right, good. Step 3. Step 3 is we are going to add electrons to peripheral atom or atoms until we have an octet. And an octet is just simply 8 electrons. So we're going to add electrons to the peripheral atoms until we have 8. Again, the exception to this is hydrogen. Hydrogen only needs 2. Needs 2, it just needs just 1 bond. That's all hydrogen needs. Okay. All right. So add electrons to the peripheral atoms. Okay, so if we take a look at this, I'm going to add 1, 2, 3, 4, 5, 6, because I already have 2 electrons on sulfur. So total oxygen has 2, 4, 6, 8 electrons. Oxygen is happy, right? If we just look, I'm just going to cross this off for a moment. If I look at just the oxygen has 8 electrons around it and it's happy. And we're going to do the same thing to the other side. 1, 2, 3, 4, 5, 6 for a total of 8 electrons. So how many electrons did I just add around the periphery? 2, 4, 6, 8, 10, 12. So I just added 12 electrons. These are the peripheral atoms to make them happy, to make sure that they have, when I say happy, I mean 8 electrons. And I am down to 2 electrons left. All right. Step 4. Really simple, no exceptions here. Add remaining electrons, if there are any, to central atom. Add remaining to the central atom. There we go. I've got 2 electrons left. There they are. Minus 2 electrons. This is the central. And I have no electrons left. This is a situation we want to be in. We don't want any electrons left. And now we are going to check our central atom. How many electrons does sulfur currently have? Because we know the 2 oxygens on the outside are happy with 8. Well, right now it has 2, 4, 6 electrons around sulfur. So sulfur needs 2 more electrons, but we don't have any more to add. So we're in this weird situation. So currently sulfur has 6, but we don't have any electrons to add. That's not good enough. We always have to have 8 electrons for everything except for hydrogen, which only has 2. So the last step of this, and this is kind of optional. It depends on where you are. So this one is optional. I guess I shouldn't say optional. It's required if you need to, right? So 5 is we are going to multiple bond if needed. To complete central atom octet. So we're going to multiple bond if needed. That's the last step here. And we see that sulfur needs 2 more electrons. So what we're simply going to do is I'm going to cross off that lone pair there, and I'm going to create a bond to sulfur. This still has 8 electrons, 2, 4, 6, 8. Now sulfur has 8 as well, so they both have 8 electrons. Okay, so that's it. This is the final structure of my SO2. Okay, so that is the proper Lewis structure for SO2. And we'll do more with that later, but you need to be able to draw these. Okay, that's it. That's going through the steps. Let's do one more, and I'll do it so you can see the structure. Let's take a look at CH2O. And here we go. Let's count the total number of electrons. So carbon is in group 4. Hydrogen is in group 1. Actually, I'll do oxygen next because it's right here. Oxygen has 6. And hydrogen, there are 2 hydrogens at 1 electron each for a total of 12 electrons. Okay, good. Step 2 is create a skeleton structure. I said carbon is always in the center. There's my carbon, oxygen, hydrogen, hydrogen. I just used 6 electrons I'm down to 6 left, right? 12 minus 6 give me 6. Instead of doing the math, I'm just, well, I guess I can. Go 12 minus 6 electrons. I have 6 electrons left. I have used 2, 4, 6. That's where that 6 comes from. Next step is step 3, add electrons to the peripheral atoms. Oxygen, 1, 2, 3, 4, 5, 6. Hydrogen is happy with just the 1 bond. I don't need to, it just needs 2 electrons, 1 bond, doesn't need anything else. This oxygen is happy, this hydrogen is happy. I just use 6 electrons, so minus 6 electrons, which are, again, on the periphery, 2, 4, 6. And so now I'm down to 0 electrons left. Fantastic. The last step is let's check my central atom. My central atom has 2, 4, 6 electrons left, or 6 electrons right now. So I'm going to cross off one of those and create a double bond with oxygen. There's my final structure for CH2O. Everything is happy. Everything has 8 except for hydrogen, which has 2, and we're good to go. Okay, that is creating Lewis structures. Let's just do one more. Let's just do one more. And I encourage you to pause this. And yeah, I encourage you to pause this and do it on your own. Let's do NO2 minus. And this one's a little bit funky in terms of counting the electrons. Nitrogen has 5. My oxygen 2 times 6. And the negative charge is actually me adding 1 extra electron, right? Negative means there's an extra electron there. So what is that? 18 electrons total. And then from here we proceed. Nitrogen is in the central, oxygen on either side. I've just lost 4, so I'm down to 14. I'm going to take care of the peripheral atoms. I've just used 12. Oh, sorry. Let's see. I've just used 12, so I'm down to 2 electrons. 2 electrons get added to the center. I'm down to no electrons. And now I have to recognize that I need to double bond. By the way, I could have completely double bonded on the other side. That's totally fine too. So either of these structures is fine. We're not going to, there's a little more complexity there, but those two are the same thing. Either one of those will work just fine. Okay. Okay. So that's it. Give a couple of these a try. You can pretty much, there's examples everywhere. I've got them on, we have them all over the place. So yeah, so give these a go. And that is that. So that is Lewis structures.